continuing on the path of proving things, we're going to take some little shortcuts just to make life easier, and you're going to find this is going to be your friend when you get into calculus. It's just called U substitution. So, for instance, if I've got 2 cosine squared theta plus 3 cosine theta plus 1 over cosine squared theta, and then plus 2 cosine theta plus 1. Okay, and I'm supposed to factor and simplify. Well, first of all, I can't combine like terms. I can't reduce because it's addition across the top and addition across the bottom. I can only reduce if I'm in multiplication. So I'm kind of sort of stuck. So what we're going to do is we're going to rewrite. And so I've got U equals cosine theta. So wherever there's a cosine, I'm just going to put a U. And that's just going to make it a little bit cleaner so we don't get completely bogged down in trig world and we can actually see what we're doing. You don't have to do substitution. It just makes it cleaner. So I've got a 2u squared plus 3u plus 1. Oop, I just crossed it out and I didn't mean to. U squared plus 2u plus 1. So now I can factor this. This is just quadratic. So the bottom is going to be u plus 1 squared. And then the top, I don't know what method you use. I don't care what method you use. I use factoring by grouping. So I'm going to multiply, because this lead coefficient isn't 1, I'm going to multiply first times last. And that's going to give me 2u squared. Okay? And I need 2 numbers that multiply to 2u squared that add up to my middle term. So they need to add up to 3u. And I feel like I've already told you how to do this, but whatever. All right, so your signs are the same. So a 2u plus a u, 2u times u is 2u squared, 2u plus u is 3u's. So I'm going to trash that middle term, put those 2 in its place. So I've got a 2u squared plus 2u plus a u plus 1. I'm going to factor out from the first 2, and I get a u plus 1. Oh no. I'm going to factor out from the last 2. So from the first 2, I factored out a 2u. From the last 2, there's nothing common, so I'm going to pull out a plus 1. Because I can divide anything by 1, which means this thing factors down to u plus 1 times, so that's what's in parentheses, you factored it out, 2u plus 1. So now I find out I can reduce. So this u plus 1 reduces with one of those u plus 1s. So my answer is 2u plus 1 over u plus 1. You cannot reduce those. Okay, because they're not like terms. This is addition over addition, so don't reduce it. But we started in trig world, we better end in trig world. So wherever there's a u, I'm going to put a cosine. So my actual answer is 2 cosine theta plus 1 over cosine theta plus 1. And it just made life a little bit cleaner to do that substitution. Again, you don't have to, but it just makes it a little bit cleaner. So let's try some more. All right, so I am going to use, what about cosine times cosecant? So I'm going to use some verbiage in here, cosecant, and I want to try and make this thing equal cotangent. So we've done some practicing, we've done some factoring, we've done some conjugates, all that kind of stuff, but now I have an actual statement. I have an identity. The left side must equal the right side. So you usually start with the more complicated side, which we normally will put on the left for you. Okay, and notice I'm not going to change cotangent unless I absolutely have to. I'm going to try and manipulate the left side until it gets to be cotangent. And so I'm just going to do stuff as I can, and I'm going to use the verbiage, and so that you get used to hearing what identities you're using, or what promises, what identities you're using. So first of all, what do I know how to do? Well, this is cosine. What is cosecant? Cosecant is the reciprocal of sine. So I am going to rewrite cosecant as 1 over sine. Okay? And now look what I know how to do. I can multiply straight across, so I end up with a cosine over a sine, and by a quotient identity, that becomes cotangent. So I just fixed it. So moving from, ooh, that was lovely. Moving from here to here, that was supposed to be a curly bracket. Curly bracket. Moving from here to here, you used a quotient, which is the answer to a division problem. You used a quotient property. Moving from here to here, I used a reciprocal property. Okay, because what's the reciprocal of cosecant? It's sine. Okay, so you'll have to identify what methods you're using. You're going to have to justify your methods. Okay, so let's try secant squared of negative theta minus 1. And I need to try and make that into a tangent squared theta. Okay, so first of all, I must have my arguments match. So this is a positive theta, this is a negative theta. And I cannot have my arguments not match. We're going to discover in the next couple sections how I can make them match. But for right now, you don't know how. So looking back at secant, I remember that secant is an even identity. And so it doesn't matter if my angle measure is positive or negative, it will produce the same ratio. So what you can kind of sort of consider is that you're ignoring that negative. Because remember, we did a parabola. If I push in a positive 4, I'll get a 16. If I push in a negative 4, I'll get a positive 16. So I can ignore the sign on this thing. So what I have now, by an even-odd identity, is I can write it this way. And now I notice I'm adding and subtracting a whole bunch of squares and ones. So I notice that secant squared minus 1 is equivalent to tangent squared. So tangent squared equals tangent squared. Okay? So up here I could have said cotangent theta, cotangent theta, cotangent theta, the whole way down. It doesn't matter. What you need to notice is that I'm just messing with the left side. Okay? So how did I move from here to here? That's a Pythagorean identity. Okay? So let's try another couple. I've got cosine theta times cotangent theta plus tangent theta equals cosecant theta. So I want this entire thing over here to change into cosecant. So again, you're going to get little prompts to tell you what steps to take, because you may be like, holy cow, I have no idea what to do. But I do notice that I'm fixing to distribute cosine through, so I may want to change these into terms of sines and cosines. So what that means is I'll have cosine theta, and then I've got cosine theta over sine theta, which is the same thing as cotangent, plus sine theta over cosine theta. And that needs to equal cosecant. So I wrote that thing in terms of sine and cosine. So now I'm going to distribute. So when I distribute this, I'll get a cosine squared. Oops. Cosine squared theta over sine theta. Okay. And then I'm going to distribute this, and I'm going to get a sine theta over cosine theta. Okay, well that appears, I lost my cosine. Okay, so that appears to have made a mess. Okay, I made it look worse than I did to make it look better. So maybe what I should do is get a common denominator. Okay, so let's get a common denominator from here. So on this one, my common denominator is going to be sine cosine. Okay, and actually let's back up the truck just a little bit. Back up that truck. And let's get a common denominator here just because it'll be cleaner. And so what I have is my common denominator is sine cosine. So I've got cosine theta, and then my common denominator is sine theta, cosine theta. Okay? And then I'm going to have, well, what do I need to do? This one needs the cosine. So I'm going to multiply top and bottom by cosine. So this becomes cosine squared. And then plus, this one needs a sine. So that part becomes sine squared. Okay? So I tried something. I didn't like how it was looking. I could have gotten a common denominator here, but it's going to be easier to do it there before I distribute. And now I notice something magical. This turns into 1 because it's a Pythagorean identity. So what I have now is the cosine of theta times 1 over sine theta cosine theta. Okay? So this whole thing right here turned into a 1. And now any number divided by itself is 1, which means I'm left with 1 over sine. So one of the things that you might get frustrated with is, well, I just made it worse. Well, I just did this. I just did that. You got to be willing to fight with it. Okay, you've got to be willing to do something and you don't like how it's going, so back up, try something else. You may have to back up and try this again. Okay, but it's how you get used to working with it. So I find out that 1 over sine is the exact same thing as cosecant by a reciprocal identity. By a reciprocal identity. So let's try a couple more. I've got the cosecant of u times the sine of u minus cosine squared of u, and I want that to be sine, oops, that's not a theta, it's a u. I want that to be sine squared of u. Okay, so I am going to concentrate on making this thing into a sine squared. Okay, so what is something I know how to do? Well, I can change this into 1 over sine. Okay, I can change this into 1 over sine. So when I change this, I'm going to get 1 over sine u times sine u minus cosine squared u. Okay, so what happens? This reduces to a 1. So now I've got 1 minus cosine squared u. So I used a reciprocal identity. I canceled. And now magically I've got a Pythagorean identity, which is going to take me to a sine squared. Okay, so, and again, they're going to give you little prompts because it ends up being a little bit overwhelming if you don't do the little prompts. So I've got a 1 plus sine theta. And I've got a 1 minus sine theta. And I want that to equal cosine squared theta. So what's something I know how to do? Well, I know how to multiply these. They are conjugates. So that's going to be a 1 minus sine theta plus sine theta minus sine squared theta. And then, holy cow, look, Pythagorean identity makes that into a cosine squared. So I ended up generating the exact same thing on the left that I needed on the right, or that I have on the right. Okay, so let's try another one. If I've got cosecant to the 4th of x minus cosecant squared of x, and I want it to equal cotangent to the 4th plus cotangent squared. That's what I want to equal. So, well, what's something I can do? Leave this side alone. I forgot my x. Leave this side alone and mess with this side. What's something I know how to do to this side? I can factor. So I can pull out a cosecant squared. So I'm going to factor out cosecant squared, which is going to leave me with cosecant squared minus 1. Okay, so if I factor out a cosecant squared, what do I get? Well, cosecant squared, where did it go? Minus 1 is cotangent squared. Okay, so this thing becomes a cotangent squared. Or I can change this, because here's the deal. If you push this into a cotangent squared, then I want to keep the fact that I've got 2 different terms going. So if I change this into a cotangent squared, I'm going to squish it into 1 term. So maybe I should change this one. Maybe I should change that one. So when I change that one, I'll end up with a 1 plus cotangent squared times cosecant squared, oops, good heavens, minus 1. And when you FOIL that out, it's going to end up reducing Okay. Well, okay, so let's look at it again. It's not going to FOIL out pretty because I'm going to have a cosecant. I'm sitting here looking at it. It's going to be a cosecant squared and then -1 and then cosecant cotangent, and it's going to be ugly and nasty. So maybe this one, because I'm trying to morph from cosecants into cotangents, maybe I need to morph that one into cotangent squared as well. So that means this becomes 1 times cotangent squared. And this is the definition of cotangent squared. And now look at there. I can distribute that and I get cotangent squared plus distribute there and I get cotangent to the 4th. So some of it, you just got to play with it and mess with it. Okay. So what I looked for is I didn't want to generate this down into a single term. I wanted to keep it in 2 terms. So I changed this using Pythagorean identity, but then I realized it was going to go ugly, so I changed that into cotangent, and then it was clear. Then I could see what I needed to do. Okay, so let's do, I think you can do the rest of these. Yes, 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 you can. Okay, so that is basically what you're going to do. The rest of these, I'm looking to see what your homework looks like, and they're going to nudge you the right direction. So if you're stuck, it's going to tell you what to do on each step. So you're not just going to have to fly through it like I'm doing. But if you, just let me know. That's going to be the end of section 8.4, but there are several more problems to do in the homework. So let me know if you're stuck.